If you're a maintenance supervisor for a commercial property, you've had to deal with everything from leaky faucets to flickering light bulbs. But nothing's worse than that ancient boiler that's lived in the building since the day it was built, 50 years ago. It's enough to make anyone lose their cool. That's where Grainger comes in. With industrial-grade products and dependable fast delivery, Grainger can help with any challenge, from worn-out components to everyday necessities. Call, click Grainger.com, or just stop by. Grainger, for the ones who get it done.
Hi there, thanks for joining us and welcome to a fresh episode of Space Nuts. My name is Andrew Dunkley, your host. It's always good to have your company. Coming up, we are going to look at the windiest planet ever discovered. This is planet Baked Beans. No, it's not. It's called something else, but it's quite extraordinary. The numbers will blow your mind. A strange area of terrain has been identified in Mars, which tells a very interesting tale about the planet's history. We're going to look at a protostar that we won't be able to look at soon, and it's also part of a triple star system. And time permitting, we are going to bring up that old chestnut again, light pollution. That's all coming up on this episode of Space Nuts.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Indeed it is. Now, Fred's still away, gallivanting around with reindeer in the northern hemisphere somewhere. And joining us in his place is Professor Jonti Horner, Professor of Astrophysics at the University of Southern Queensland. Hi, Jonti.
G'day, how are you going?
Good. And you?
Oh, getting there slowly, a little bit sniffly. We're having the joys of summer around here, so it's been nice and dry and warm for the last few days, so all the plants have been getting too excited. And I think I'm suffering a little bit from their excitement.
Our plants are very unexcited because we're going to hit 42 Celsius today. And I've got the air conditioning on, and it usually cuts itself off pretty quickly this time of the day because, it equalizes through the thermostat. It has been running nonstop for 45 minutes now because it cannot keep the temperature down because it's so hot outside right at the moment. We're going.
One of the beauties of the Darling Downs here is that our heat waves don't get quite that extreme. I think further west they do. But this area around Toowoomba is just really lovely. So our summers are pretty much 30 to 35 most days, but gets cool enough at night to sleep still, and very rare that we'll get up near to 40. I think in the couple of years I've been in this house, we've not hit 40 yet. And yet we don't have all the humidity that makes Brisbane the kind of world's armpit.
It's no place by the sound of it, Jonti. Well, I tell you who likes this kind of weather. It's the local snake population. I drove into our, we live in a gated estate. I drove in yesterday and saw what I thought was a piece of plastic hose on the road. No, it wasn't. It was a 5-foot eastern brown snake crossing the road, minding its own business. But that's the third time we've seen one this summer. If you want to have a look at it, I've put photos of it on Instagram and TikTok. So, it was a big one. I let him go.
All the old sayings say, they're more scared of you than you are of them. I love the Australian thing. But when I moved out here from the UK, everybody was kind of, oh no, you're going, all the animals will kill you, the drop dead will get you all this stuff.
Drop deads, yes.
So I got a book called Australia's Most Dangerous Animals, which is only a little one. Turns out the most dangerous animal in Australia, according to that book, is not sharks or snakes. I mean, obviously it's people, but aside from people, it's the European honeybee, because people are allergic to them, and they are in. And that really puts it in perspective. It's the case that Australia has all these animals that can be dangerous, but they're also nearly all cowards. So they'll typically get out of your way. It's not like the rattlesnakes in the US, or I think, is it cobras in the subcontinent, where they'll actually aggressively defend themselves. The snakes here just want to run away.
Yes.
So, tail between the legs, shoot off.
Yes. If they had legs, they could probably do that. Yep. Now, we should get on with it because we've got a lot to talk about. We're going to focus firstly on the windiest planet ever discovered, planet Baked Beans. It's not. It's Wasp 127b. Tell us all about it.
The joys of catalogue numbers that do exactly what they say on their tin. Incidentally, for those who are not so keen on the catalogue numbers that are given to exoplanets, which are really useful to astronomers but not really good for everybody's imagination, the International Astronomical Union are slowly naming planets and their stars, and they're doing it in a very kind of democratic, global, community-type fashion. And this one hasn't yet been named, but it may well be in the future. So names coming soon. Probably people will nominate baked beans given this story, but we'll just have to see how that ends out. Wasp 127b is a planet that was found using the transit method. So the Wasp program is a wide-angle search for planets, and they've got this array of essentially pretty good DSLR cameras with wide-angle lenses all strapped together that have been staring at the same patch of the night sky whenever it's above the horizon for a long, long time. And they have a couple of stations around the world. And what this lets them do is monitor the brightness of all the stars in that field of view and look for any of them that periodically wink at us. And this is the same technique that NASA's Kepler mission uses, that the TESS mission uses as well. And they find planets by looking at the planets passing between us and the star, blocking out some of that light and causing the star to dim and then brighten. And it's a technique that is really effective, but it's very biased towards finding planets that are big, because a bigger planet blocks more light, and also finding planets that are nearer to the star, because the planet that's nearer to the star goes around more quickly, so you get more winks in a given period of time. And that's very true of this planet. This is a planet that's big. It's 1 1/3 times larger than Jupiter in terms of diameter. It's also quite light. It's less massive than Saturn. It's about 1/5 of Jupiter's mass, which means it's one of the least dense planets we know. People describe it as a super puff. But because it's big, it's got this big diameter, it blocks quite a big chunk of its star's light, making it relatively obvious for people to detect. And it goes around every 4 days. So this star winks at us every 4 days or so. And that's how this planet was discovered. Now, because it's big, because its star's quite bright, it's a really prime target for people to look at to see if they can learn more about it. We want to develop the tools to study the atmospheres of planets around other stars and learn more about them. So not to just know that they're there, but actually characterize them. And that helps us understand how planets form, what the diversity of planets is, and all the rest of it. And this has been a prime target for that kind of work for a few years. The new results that have come out are the result of people trying to study the atmosphere of this planet. They used a very large telescope, which is remarkably imaginatively named, and they were getting observations with this huge ground-based telescope to study the spectra of this planet. So to take the light that we get from the planet separately from the star, break it into its component colors, and look at what spectral lines are in there, because the spectral lines give you the fingerprint of the composition of the atmosphere. Mm-hmm. They also tell you things like how quickly the atmosphere is moving, how hot it is, and with enough information, you can even start inferring things about the structure, where the clouds are, things like that. Now, this is really cutting edge, so even with the biggest telescopes in the world, we can only really do it for big, fluffy planets that are very near their stars. We're nowhere near being able to do it for planets like Earth yet, but it's a step on that journey. So that's the background here. What happened with this planet is that the observations, when they got the spectra, it revealed something really weird. For the different things in the atmosphere, instead of having a single peak in the spectrum that said, hey, look, here we've got hydrogen or whatever, they found 2 peaks quite close together, but certainly quite separate from one another, distinctly separate. And this puzzled them for a little bit, and there was a bit of a continuum between them as well. So it wasn't just like one narrow spike and a gap and another narrow spike. But what they realized was that thanks to the Doppler effect, just exactly the same kind of thing we use for the radial velocity measurements that we do of stars to measure their wobbles, if you've got gas that's coming towards the Earth, light that it emits and light that it absorbs, that light will be blue shifted. The wavelength will be shorter than it would be if that was stationary. If that gas is moving away from us, the light's stretched out and so the light's red shifted. And the degree to which the light is blue or red shifted tells you the speed. The quicker it's moving, the bigger the shift is. You know, this is the same thing you get if a police car or an ambulance comes past. You know, you hear the siren when it's approaching and it's high-pitched and fast. You hear like, Nino, Nino, Nino. And then it goes past and it's going away and you hear Nino, Nino. And the faster it's going, the bigger the shift is. So when they're in a real hurry, it's really distinct. That allows them to figure out what's going on here. So it turns out that this planet is the victim of incredibly high wind speeds. There's extreme weather going on. And what they think it is best described as is like an equatorial jet, where you've got winds going around the planet at ridiculously high speed. Now, this is a planet that goes around its star every 4 days. Its surface temperature of the cloud tops is like 1100 degrees C. So it's really extreme anyway. But the wind speed to explain these two peaks must be about 33,000 kilometers per hour. So that's 9 kilometers per second, which is just ridiculous. And you've got the blue shifted peak because on one side of the planet, the wind's coming towards us. And the red shifted peak because on the other side of the planet, on the other edge of the planet, the wind's going away from us. So you get this peak to peak width of about 18 kilometers a second between 9 kilometers a second towards us and 9 kilometers per second away. Putting that in scale, that is 16 times faster than the fastest winds we've ever seen in the solar system, which are the 200 kilometer per hour winds on Neptune, and is therefore something like 160, 150 times stronger than the strongest wind gust ever recorded on Earth. So that's just insane, remarkable wind speed, and it tells us a lot about the properties of the atmosphere. There's going to be a lot we'll learn about it in terms of how energy is moved from the daylight side to the nighttime side, because this planet should be tidally locked. So it should keep one side facing towards the star, one side facing away. And these winds are probably what's transferring the heat from the daytime side, which is super hot, round to the night side, which is colder.
I was going to get to that. Yeah, that makes perfect sense. So you're getting superheated on one side, and it's just going around and around.
Absolutely. And it's a bit more than anybody would have expected to find, but that's the nature of this kind of exploration. I always think it's true of most things in astronomy that the closer you are to the conditions that are in your room right now, the better we understand it. So the further we go away from standard temperature, room pressure, the less understanding we have, the more we have to learn. Now, we've got guideposts in our solar system, so we've learned a bit about planets that are like the solar system planets. But when it comes to something like this super hot, super puffy planet around this star that is similar to, but a bit bigger and a bit hotter than the sun, it's totally different to anything we've ever seen and experienced. And therefore, you get results you don't expect. And in understanding those, we get a better handle of how planets work.
Yes, fascinating. How does it compare to the gas giants in our solar system? I mean, they're much further away from their star, so there's the first.
Further away, but there's still a lot of interesting things happening energy-wise. We've got a lot of data for Jupiter and Saturn and more limited data from the Voyager spacecraft that went to Uranus and Neptune. We've basically been to Jupiter and Saturn more often. Yeah. But the highest speeds that we've ever observed in the solar system are those on Neptune, which are about 2,000 kilometers per hour. Now, that is pretty impressive from an Earth-based point of view, and was a big surprise because Neptune's so far from the sun, it's got so little energy that was a surprise. And it turns out it's due to the energy coming from the interior of the planet, in part, as well as the solar radiation getting there. Yeah, that was a shock. But this is 16 times stronger than you get on Neptune. Like I say, it's about 170 times stronger than our strongest wind here on Earth, 150 times. I think there was a cyclone, a typhoon, be a hurricane because of the basin it's in, Hurricane Patricia a few years ago that rapidly intensified and became the strongest in terms of continuous wind speed on Earth that we'd ever observed. And that was 215 kilometers per hour as a continuous wind speed, with gusts normally up to 50% higher than that.
Yeah.
So, I mean, if you said that the gusts were 330 kilometers per hour, this is 100 times that.
Wow. Yeah, they're big numbers, aren't they? But what was it? 33,000 kilometers an hour, 20,500 miles an hour for our American friend. That's outrageous. Kite flyers would be so very thrilled.
Well, I mean, to put it another way, that's basically like the circumference of the Earth every hour, isn't it?
It would be close, yes.
I'm just going to double check my distance there. Almost. So Earth's circumference is about 40,000. So if you could travel at the speed of this wind, then you'd be able to get around the Earth in about every 70 minutes. The International Space Station goes around about every 90 minutes. So its speed is faster than the speed that the space station is orbiting Earth.
Fascinating, yes. Well, there it is. The windiest planet ever discovered. Edgel, take a bow. Now, Jonti, let's move on to our next story. This is another discovery on Mars. A strange area of terrain has been identified. It's not so much what it looks like that is the discovery, although that is true. It's what it tells us about the history of the planet that's even more fascinating.
Yeah, this struck me really when I read it, was really interesting, but particularly given that it speaks something very similar to the kind of terrain I've got locally. So the Darling Downs here are quite striking because you've got these flat-topped mesas which stand a few hundred meters above the rest of the terrain here. And it's a very flat area, but with these distinct areas that are raised up with flat tops. Some of them are more hill-shaped. And this is a similar area on Mars. It's an area of what are described as buttes and mesas, which date back a huge amount of time. It's in the northern hemisphere of Mars, which is this lowland area with far fewer craters than the southern highlands. So it's a low terrain with lots and lots of, a lot of lack of craters compared to the southern hemisphere, which has long been argued to be the place that you'd expect to have had an ocean on Mars in the very distant past. And that remains somewhat controversial. Other explanations are available. And in fact, there's a study came out in the last week looking at Mars quakes, arguing that the origin of these terrains may not have been a giant impact like we think, but could have been linked to plate tectonics. So there's a lot of discussion and a lot of study going on with this. But the general consensus is that that northern area of Mars, the lowlands, has been heavily resurfaced when Mars was young, and that's why you've got fewer craters there, 'cause it's had less time to build up the craters. And that's kind of the evidence for the ocean, or one of the big bits of the evidence for the ocean. If you took the Earth's oceans away, you'd honestly see a very similar thing. The ocean floor has far fewer craters than the rest of the Earth's surface.
Yeah.
Now, what's interesting with this area is that the team who studied it have used data from a number of instruments, the high-rise cameras which are going around Mars, data from Mars Reconnaissance Orbiter, Mars Express, and the ExoMars Trace Gas Analyzer. So they've got loads of data from lots of different sources, looking at this area with the butts and the mesas. And what they've found is that on the sides of them, where it's been weathered away, you've got evidence of a huge depth of material that are clays. So this is very clay material, stretching up to 350 meters vertically. So really big depth of clay material. Now, the idea seems to be that originally, whatever it was that created that area laid down deposits as a fairly flat layer up to the height of what we see as the tops of the butts and mesas. This is my understanding. And then over billions of years, that's been weathered away, just like what's happening here. So the areas with the flatter tops are areas where there's been a slightly stronger material on top, and weathering hasn't happened, so they've been weathered around that.
Yeah.
So exposing these layers of clays is exposing almost like a chronological sequence of material that has been deposited. So to have 350 meters depth of clay materials is really interesting because these clays only form in the presence of liquid water. It needs to be permanent liquid water. It can't just be that you got a few drops of water on a rock. That doesn't give you clay.
Okay.
So to have this depth of clays is suggesting that there was permanent liquid water above this area for a very long time. You're looking at deposits from that. And that is really strong evidence that there was permanent liquid water over a very lengthy period of time in the area on Mars that everybody has been arguing for ages was once home to an ocean. So it seems to be yet another piece of evidence for the presence of that kind of northern hemisphere beautiful ocean, kind of 3.5-4 billion years ago in the ancient past. Now that's really exciting in and of itself, but there's a nice additional twist, which is that this area, which looks now so exciting where there's this strong evidence of clay materials, is tied to part of Mars that we call Oxyplanum. And that's going to be the destination for the European Rosalind Franklin mission. Now, that mission was meant to launch 3 or 4 years ago as a joint initiative between the Europeans and the Russians. But when everything that's going on with Russia and the Ukraine kicked off, the Europeans pulled their collaboration with Russia, which meant that they had to rebuild a lot of stuff because they had to now do what the Russians were going to do for them, and that delayed things. So it's now purely a European mission. It looks like it's going to launch in 2028. And it is a mission that is designed very specifically to look for evidence of life on Mars, particularly past life. And the name Rosalind Franklin, of course, comes from the incredibly gifted researcher who did most of the work that led to Crick and Watson getting the Nobel Prize for the structure of DNA. But unfortunately, she passed away before the prize was awarded at a very young age. So it's nice to see her honoured, and it's a nice thing to go together that the place that mission is going to go now looks even more interesting than it did before. So it's like they've chosen the perfect site.
Yeah, look, we are learning more and more and more. The evidence is stacking up. Are we very far away from saying definitively, okay, this was what Mars was like at this time, no questions asked?
I'd like to think so. I mean, it's one of the cool things about astronomy, and particularly this kind of planetary science, that speaks to the kind of detective story fans. Because what we're doing effectively is studying a crime scene that is 4 billion years old, and we're trying to piece together all the clues. And we're trying to piece together a narrative that explains what we see, that makes sense, that fits together. And there will always be other possibilities that can explain it. But with every bit of evidence we get, what happens is that the number of possible explanations gets whittled down. Because a new observation, a new discovery will say that, well, this explanation no longer makes sense, it no longer works. So we're building towards this more robust understanding. I mean, personally, my instinct is that it looks like an ocean. It looks like what you would expect if an ocean had been there. And the fact we're getting more and more evidence that supports that is really encouraging. When it becomes absolutely and definitively accepted, I'm not entirely sure, but I'm sure Rosalind Franklin will really help with that.
We're lucky because we've got a planet we can compare it to. So we can see evidence here that equates to things there. We can go, okay, well, this is the same. This is a piece of history that Earth shared with Mars. And that kind of narrows down the possibilities significantly. We don't have to go there. Well, we do, but we don't have to go there directly sometimes to sort of compare notes. It's fascinating.
It's fabulous. It's a really interesting contrast with exoplanets. So on the one hand, we've got this one planetary system that we've known since we've known about the universe, essentially, where we've got incredibly fine levels of detail. The fact that we can talk, as we are doing here, about a relatively small area on the surface of a given planet that we've imaged and where we're sending a spacecraft. So we know the solar system objects in incredible exquisite detail, this wealth of information that's sometimes almost too overwhelming for us to actually be able to work out what that planet's all about. For exoplanets, for most of them, we only know that they're there and maybe how massive they are or how big they are. But we know far more of them and more diversity. So on the one hand, we've got one system we know incredibly well with more than 1 million objects in it that we've studied. For all the others, we know 1 or 2 objects and we know a little bit about them. But by learning more about them, we'll learn more about the solar system. And by better studying the planets in the solar system, that gives us a ground truth to work from for exoplanets. So it's 2 fields that are very different, but linked together really nicely.
Yes, indeed. All right. Really interesting history. And I suppose just to add a little bit more to that, we look at the history of Earth and, I still struggle to get my head around the fact that there used to be rainforests in Antarctica. These things have taken millions of years to change, or tens of thousands of years in some circumstances. So we shouldn't be surprised by a planet like Mars having had oceans and rivers and all those other things. So, yeah. This is Space Nuts. You're with Andrew Dunkley and Professor Jonti Horner.
Roger, your labs are here also.
Space Nuts.
Now, Jonti, not your area of expertise, but I know you've done your homework. A protostar, which I'll get you to explain, give us a definition of, is soon going to disappear for what will be obvious reasons, but it's part of a triple star system. This is all very intriguing.
It is. This is a star in the constellation Taurus that is kind of the archetypal example of a protostar that's nearly but not quite a fully grown star. So it's a star that is still in the latter stages of finalizing its formation. It's still condensing under gravity. It has got a bit of nuclear fusion going on, but it's not settled down. It's not become what we call a main sequence star like the sun yet. Now it's relatively bright and easy to study. So that means amateur astronomers around the world are getting measurements of the brightness of this star all the time. It's about magnitude 12, magnitude 11-ish, which means that it is about 100 to 200 times too faint to see with the naked eye, but it's well within the reach of amateur telescopes. And we've got this long history of observations of it. Now, as we got better observations of it and the area that's in, it's part of a huge star-forming area. When observations started coming in the infrared, it was revealed that there were 2 other protostars nearby that you can't see in optical. You can't see them with telescopes. So this then became known as T Tauri North, and the other 2 are T Tauri South A and T Tauri South B. And it turns out that all 3 of them are moving together. So you've essentially got T Tauri South A and B is a much closer binary with a circumbinary disk of material, a disk from which planets are probably forming as we speak. And that disk is really thick. And it just so happens that that disk is edge on to us. So the light from those stars trying to reach us is passing through the disk and absorbed. We can't see it optically. There's more than 20 magnitudes of extinction, which means if those stars would normally be magnitude 10 or 11, they're instead magnitude 30 or 31 and just way beyond anything we can observe. But infrared radiation can make it through the dust so we can see that they're there. Then T Tauri North, the star we've always known as T Tauri, is a bit away from those stars, also orbiting their common center of gravity, the kind of third component of this triple system. And it too has a protoplanetary disk. It's got a disk around it where planets are forming as well. But fortunately for us, instead of being edge on, that disk is tilted so that we can see directly to the star. So we see T Tauri, and it's bright, and we can observe it, and we've learned a lot from it. But over the last couple of years, those amateur astronomers that have been reporting its magnitude and studying it continuously have seen it fade a couple of times by 1 or 2 magnitudes, then brighten up again. And that caught people's interest because you wouldn't really expect this protostar to be variable like that. So there's something interesting going on. And as we've got more information and better images from the professional telescopes, what it appears to be is that orbital motion of the binary star and then the extra component T Tauri, that orbital motion, I think the orbital period is about 4,600 years. And slowly over time, the more distant component, the one we can see, is moving so that it's going to pass behind the disk of material around the binary. And we know that that disk is thick enough to obscure the binary, and T Tauri is going to be ducking behind it. So what that means is that those dimmings we've seen have essentially been the light from that star passing through the outskirts of this disk of material. And in the coming years, therefore, it's going to be moving properly behind that disk, so long as we've got the orbital motion right. And will gradually dim to the point we won't be able to see it with the optical instruments, with these telescopes that the amateurs are using. It'll fade away, fade to black. Still be visible in the infrared, but it'll take about 100 years for it to traverse behind this disk before it starts to reappear again. So, from the point of view of optical observers, the next few years will be interesting as it fades out. But for professional astronomers, it's a really promising and valuable opportunity, because if we can predict this in advance and we can see it happening, then we can do observations of the light from that protostar as it passes through the outskirts of the disk and as it moves through the disk, which allows us to probe different locations in the disk, get an idea of what the chemistry of the disk is like, what the particle size distribution is. Is it mainly small particles? Are the bigger bits in there? How is the planet formation process progressing? We can almost get a density profile as the star moves through. It's like scanning at different locations. So it is simultaneously a little bit sad because the star's going to go away. I mean, it's coming back, so it's not the end of the world. But it's also really, really exciting because it should be such a wealth of scientific information for us to better understand how planets form.
Speaking of the end of the world, is this the development of a 3-body problem?
Possibly. Now, triple star systems like this are not that uncommon. I mean, a common joke among astronomers, which probably tells you that astronomers aren't very funny, is that more than 1 in every 1 star is in a multiple star system.
Yep.
Which is a bit specious, really. So the reality seems to be that around 50% of stars, give or take, so this is a hand-waving number, it could be as low as 40%, as high as 60%, but roughly 50% of stars are single, which means the other half of stars are all in multiple star systems. So to clarify this, I'm not talking about the individual stars, but I'm on about the systems as we see them.
Yep.
So 50% of star systems are stars on their own. 50% of star systems are not stars on their own, which means that the majority of stars are in multiple star systems because of the numbers. Even if you just assume that the other 50% are double stars before you get to these higher level hierarchical things, 50% of systems have 2 stars, 50% have 1 star. So that means 2/3 of stars are in double systems. That is more complex. But yeah, it shows that astronomers don't have a great sense of humor. But what it also points out is that multiple star systems are far from the exception. They're really the norm. And we're seeing planet formation happening in these systems, and we're discovering planets in them. We found planets that are almost kind of analogs to Tatooine from Star Wars, where there are 2 stars in the middle quite close together, and the planets orbiting on the outside, orbiting both of them at once. We've also seen systems where there are 2 stars that are quite widely separated and a planet's going around one of them. We found planets in triple and quadruple star systems as well. And this is just going to be another one of those type of systems, setting up for the future.
Okay. We do see on Earth that issue of single and multiple star systems. You've got solo artists and you've got bands.
Absolutely.
They're all made up of stars, some of them. Yes, fascinating story, and we'll watch with interest. How many billion years before we know the result of this?
We should see it happening over the next few years. Now, I should say that this isn't without precedent, and keen amateur astronomers listening to the podcast will be aware of a star called Epsilon Aurigae, which confused people for ages. So we've known about variable stars for a long time. The traditional owners of the land here in Australia have been very aware of the intrinsic variability of stars like Betelgeuse and Aldebaran, which vary kind of spasmodically over periods of a few hundred days. But we're also aware of eclipsing binary stars. And a great astronomer called Goodrich, way back a couple of hundred years ago, figured out the reason for this. He's a fascinating character to read about. He died very young. He was an amateur astronomer, but he explained the periodic variations of the star Algol, the winking demon star, by explaining that there were two stars going around each other, and when they blocked each other out, the light would dim. And you get this star dimming every few days by enough to see with the naked eye and then brightening again. So we kind of understood that. But Epsilon Aurigae really puzzled people for a long time. It's a star in the northern constellation Aurigae. You can see it from Australia, but it's quite low to the north. That every 27 years or so dims for a couple of years by more than a magnitude. So this, again, is easy to see with the naked eye, but you can't explain that as a binary star. That isn't one star passing in front of another because it doesn't take 2 years for the eclipse to happen. That star would have to be immeasurably vast and therefore should be really bright or really red. Doesn't happen. Over the last 50 years or so, people realized the explanation for that was probably that this was a binary star system where the second star in the system had a really big disk around it, a protoplanetary disk. And this was finally confirmed with the most recent of the dimmings, where we finally got to the technology point where we can do it. So it's a similar story to the one we've just talked about. But that's kind of the archetypal system where you've got an eclipse caused by the disk rather than the star. And because the disk is big, in the case of Epsilon Aurigae, it's probably bigger than the distance between the Earth and Pluto. Probably about 50 AU in radius, 100 AU across, where 1 AU is the distance from the Earth to the Sun. And that takes a couple of years as it's moving around in its orbit to pass in front of the background star, the brighter star, causing it to dim, causing that behavior. And this is just another example of that. But in this case, the disk is much thicker, so T Tauri will essentially disappear.
Okay, but not forever.
0G, and I feel fine.
Space nuts.
Let's very quickly look at one more story. This is something that Fred and I talk about quite regularly, so I'm sure he'll raise it again when he gets back. But there are concerns about light pollution affecting the extremely large telescope. Now, this is a real worry because this telescope's probably one of the more significant ones on the planet. And yeah, there are a few people getting their feathers ruffled by this.
It is. And the story here, like I say, we'll just cover it briefly, and I'm sure Fred will dive into it in a bit more detail. We'll hopefully get solved. That's the first thing today. It's still early days with this. But the extremely large telescope is built on top of what's called Cerro Amazonas, this peak in Chile's Atacama Desert that is basically one of the darkest sites on the planet. And this site was specifically chosen because there was so little light pollution that it would facilitate the incredible work this enormous telescope is going to do. And this telescope is, something like $1 billion project. It's a really expensive thing, maybe even more than that. That it's been built there. Chile is fully on board, obviously, building it on their land. The site has been bought. It's going to be an expensive deal to make. But there are real concerns now because there is an American company that is wanting to build a renewable energy plant. And it's going to be a huge plant. It's primarily to manufacture hydrogen, but it's also going to have huge amounts of solar panels and things like that. And that is a $10 billion scale project. But they want to build this within just a few kilometers of the site for a lot of these telescopes, like the site for the Very Large Telescope, stuff like this. Now, that is a real concern because this will generate a huge amount of light pollution because it'll be lit up, essentially. And that, it is thought, would possibly reduce the effectiveness of both the telescopes that are already there, but also the extremely large telescope by 10% or more, which is a huge impact. And it really lessens the relevance of that telescope when it's trying to do cutting-edge stuff, when it's trying to compete with the giant Magellan telescope, and if it ever gets built, the one that they were going to put on Hawaii as well, although that's still under debate, the 30-meter telescope. Now, this isn't insurmountable. The Chileans have said that this project is only in the early stages of proposal. The people involved with the building of the telescope have pointed out that there is no specific reason why the site that's proposed for the renewable energy place is the only place they could build it. They could build it somewhere else. But it's a real challenge because you're talking about a $1.5 billion telescope versus a $10 billion industrial park that'll create jobs. So I can understand the conflict for the Chilean government. But also, if you can find a happy medium where the two don't interfere with each other, that'll be brilliant, particularly if the observatory can then make use of the renewable energy and cut its energy budget. It's one of these situations, like many, that isn't truly black and white, but there's a lot of complexity, a lot of shades of grey in it. And the hope is that it gets sorted. The Chilean Impact Agency that assesses these things put a statement out at the end of last year saying that the project's in its early stages, no decision has been made. And I suspect the information has come out now to help ensure that people are aware of the problem so that the right decision gets made. Because if you don't talk about it, if nobody's aware of it, mistakes get made, and it's very hard to change it after the fact.
Yes, indeed. But it would be fairly tragic for the telescopes in the area because they're estimating that renewable energy project would increase the brightness of the area by 10%. That is a huge increase.
Oh, absolutely. And I mean, you see it everywhere. I'm very aware where I live. I've moved out a couple of years ago to this beautiful house that we're in now, and it's got quite dark skies. But they have built a new industrial park about 15 k's away that I pass every day going into work. And one of the places there sells tractors because we're a big agricultural area. And their building is surrounded by floodlights to obviously illuminate things to prevent thieves. Or I always think that when you're illuminating things like that, what you're actually doing is giving a shopping list to the thieves. Look at all this fabulous stuff you could take away with you. Yes. But these floodlights have really noticeably, from about 15 k's away, increased the brightness of the sky from my house to the southeast. Now, I want to be looking to the north here, so it's not the end of the world for me personally. But it's a really good example of how a single piece of building, a single project, can hugely impact the light for a very large area around with no indication of malice. People aren't doing this deliberately.
No.
But they're doing it in ignorance of the impact they have because they're not there themselves looking. And when they're looking at their products, their local area. It's a challenge, and it's hard to get people's hearts and mind on board. If you get aggressive and combative with it, it's a lot better to try and discuss it and let people know. Because at the end of the day, if they turn those spotlights and point them down, that will mean less light pollution. And the only thing it will mean from their point of view is that burglars coming in by helicopter have a slightly easier time of it.
Yes, good point. And that happens a lot.
Oh, absolutely.
Yeah. I'm sure Fred will be keen to talk about this one. Having visited the area himself and looked at the work going on there, this will really be something that will bother him, I expect. Anyway, yes, it's a work in progress. But if you'd like to chase up any of the stories we've talked about today, I think you'll find all of them on space.com. Fabulous website. And we really appreciate the work they do. And if you would like to chase anything up between episodes, by all means, go to our website. You can check out the notes on each episode at spacenutspodcast.com or spacenuts.io. And while you're there, have a look around. You can visit the shop where you can get one of these. This is a Space Nuts shirt with our logo on it, designed by my good brother Steve. Or you can hit the supporter button if you'd like to become a supporter of Space Nuts, whatever floats your boat. Jonti, thank you so much. We'll catch you on the very next episode.
Absolutely. Looking forward to it. Thank you for having me.
Professor Jonti Horner, Professor of Astrophysics at the University of Southern Queensland, our expert voice on this episode of Space Nuts. And to Hugh in the studio, he couldn't find his way in because of the light pollution around his place. And from me, Andrew Dunkley, thanks for your company. I'll catch you on the next episode of Space Nuts. See you then. Bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.